Don't forget to divide by h first.
Oh,
That's right. You got any questions about that?
no, I know.
It's a lot of work and it's a lot of steps, but it's not that hard to do. But it is very easy to make a mistake. Um, when I was reading your summary and it said conics, I thought that we were like graphing and drawing conics. Is that not true?
Yeah, at least in the quiz there wasn't as much tracking things, but there were some. There was like graph, or it says like there was given the table of values of x and f of x. Well, what is the limit x zero of x? And it has like just a bunch of things. Like there are like three kinds of problems that have to do with graph, I guess.
Okay. Um, so did you guys go through all of like limit theory? Like if I give you two functions and a limit, it tells you to like find what the limit is. Did you guys talk about when you get 0 over 0 and that kind of stuff? Did you guys do all of that?
Um, there's okay. It's alright. So done. I don't know if this is it or not, but
Piecewise functions, I'm guessing.
so that's why. And then there's that problem. That's like
So it gives you that piecewise function along with the graph of it?
no, that's different.
Okay.
This is different. Um,
So is this right here Is that -5?
Yeah.
Okay.
Mhm.
Does it give you the value for the y here?
Yeah, it's a -2. And then it's -4.
Okay. Let me ask you a question. When you do the limit and
Mm-hmm.
you have this value here and it's an actual math question, right? Like the ones we did before,
Yeah.
don't we stick that number in?
Yeah.
So if the number is equal to 4, then which one of these do you use? The bottom one or the top one? Which equation?
Bottom
The bottom one. So what would your answer be?
3.
Right. That's all you're doing. You get that part, right?
Yeah, or it's no.
So the number doesn't actually have to be there, just like in the picture that you drew here. It's
Mm-hmm.
just asking what number is it close to. And when
Okay.
they ask for f of x, that's another way of saying what?
So Y.
Right. So what is the y in that case, in that picture?
Uh, 3.
I'm sorry, I'm going to this question right here.
Oh, sorry. So -2.
It's negative. It's negative. Oh, it should be, I guess, 2, because I wrote 2 there. I didn't mean to write -2. Sorry. I was trying to say that that is 2.
Yeah, 2.
Did they talk about something that looks like this? Did you guys do anything that looked like that?
I don't think so.
Okay. So that your teacher never talked to you about, she never talked to you about like approaching from the negative side or the positive side, right?
Mm-mm.
Okay. That's probably going to be for calculus next year. I'm actually surprised that you were actually even doing limits in pre-cal. But it's the first thing that you do in calculus anyway. So,
They also have problems where the limit x is like infinity.
okay,
Yeah.
can you show me one of those then, please?
Yeah. There are actually two command. There's that one and there is. Oh, here's your five.
The top one should be undefined, right?
Yeah.
Do
Yeah,
you,
or the way to. Yes, that's
and
right.
then and then the bottom one should be -1/2, right?
Yeah,
Do you know how to get there?
I did when I went over it with you.
Um, I want to see what you do, and then I will show you an easy way to do it. That's why I can do it in my head.
Okay.
But I want to see what your teacher taught you. Oh my. Really? Y'all used a long division?
Yeah.
Okay, I'm going to stop you. I'm not going to make you do that.
Okay.
Sorry. Um, let me show you an easy way to do this. Okay? So I'm going to erase what you wrote there. Whew, Lord. Sorry. So I want you to answer a question for me. What is the highest power of x here? The
2.
top one. 2, right?
Mm-hmm.
So what I'm going to do is I'm going to multiply the top and the bottom by the highest power of x.
Mm-hmm.
When I do that, am I changing the function?
No.
No, because that's a form of 1, right?
Mm-hmm.
So I'm going to multiply it through, and I get 1 plus 11 over x plus 33 over x squared.
Mm-hmm.
And then the bottom becomes 1 over x plus 6 over x squared. Do you see how I got both of those?
Yeah.
Okay, now I'm going to stick in my limit. And you can do infinite limits this way all the time, unless you get infinity over infinity. Then we have to do something else. But since she didn't give you any that did that, you might not be doing ones that are that hard. Okay?
Mm-hmm.
So if I stick in infinity there, what is any number divided by infinity? Do you know?
Oh, is it just 0?
It's
Is it
0. It's 0. So all of these are going to cancel out, right?
Mm-hmm.
So I get 1 plus 0 on the top. And then I get divided by 0 on the bottom. Because that's 0 and that's 0, right?
Yeah.
And because I have this, that's why it's undefined.
Mm-hmm.
For this question down here, I'm going to do the exact same thing. What's the highest power of x?
1.
1. So I'm going to multiply the top and the bottom by 1 over x. And I get 1 over x minus 3. And I get 1 over x plus 6. And then I put my limit in. What happens to these two things?
There's 0.
They're 0. So I'm left with 3 over 6. And so that's equal to negative 1/2.
I think that's the same way that my teacher did for the second one. For the first one, she did one division.
Okay.
Or she actually. Oh, wait, yeah. Okay.
She did the same thing?
Yeah, she just wrote divided by x instead of 1 over x. It's the same thing.
Yeah.
Yeah. So that's what she did.
So whenever you have an infinity one,
Mm-hmm.
make sure you use that technique. If you get 0 over 0, or if you get infinity over infinity, then you're going to have to do some factoring in order to simplify the original thing to use that trick. Because there's going to be something else that you can do to it in order to simplify it.
Okay.
Did that ever happen in your homework? Do you remember that happening?
I don't think so.
Okay. So I wouldn't worry about it. Because again, this is stuff that you learn in calculus next year. Or, I don't know, what are you going to take next year? What do you have to take next year?
I'm not sure. I can't register for any classes until 15.
And
So,
I guess you have to take the entrance exam to figure out where they're going to place you anyway, right?
yeah.
Yeah.
Oh, there was one other kind I didn't know what to do with.
You want to write it up and then we work through it?
Yeah.
Okay. While you're writing that up, I'll be right back. I'm going to run to the restroom.
Okay.
Do you know how to do that?
No.
The answer is -8, right?
Yeah. Yeah.
Let me ask you this question. What is that equal to?
1.
Mm-hmm. What is that equal to?
1.
What is this equal to?
1.
So when you stick the 2 in here, what do you get for the exponent of the e?
0.
So what do you think e to the 0 is equal to?
1.
What's 1 times -8?
Negative.
Does that make sense now?
Yeah. Yeah. Okay.
Did you have any limits that you actually had to factor?
Yeah. I have that. Um.
Right. Yeah, go ahead. When you initially stick in -3, what do you get for the top?
Alright. 9 minus 21 plus 12.
Which is equal to what?
22. Yeah. Oh wait.
You got 9 minus 21 plus 12.
0.
That's 0. When you stick that number into the bottom, what do you get?
0.
So, and that's kind of what I was talking about before. Whenever you see 0 over 0, there's something else that you can do to simplify this so you actually get a limit. Because in your graph, and I'm not saying that this is the graph of this, but what I'm saying is let's say that's your picture.
Mm-hmm.
At -3, there's a hole.
Mm-hmm.
So in order to figure out where exactly that hole is, you're going to have to factor this. So you get x plus 3 over x plus 4 divided by x plus 3.
Mm-hmm.
And then these two things cancel, and now you can actually stick in your limit. And so when you stick in your limit, what do you get?
1.
1. And so this hole would be at 3, comma 1.
Mm-hmm. Mm-hmm. Yeah. Okay.
The same thing might happen when you're doing infinity over infinity.
Mm-hmm. Okay.
But I want you to be careful, because if you get something that's like this would be an actual limit. It would just be undefined.
Okay.
Okay?
Mm-hmm.
And you could also get, and that limit is just 0. So you can get 0 as a limit too. And I know that those two cases mess most of my students up because they think that that can't be a right answer.
Mm-hmm. Okay.
You're basically leading me today. Anything else I can answer for you, I will do. We got like 15 minutes left.
Mm-hmm. Um, there's limited or like about Moore's theorem. Yeah. Uh, just yeah, that's all it says. It's, it just says to represent each of the roots graphically and express each of the roots in standard form.
Express each of the roots in standard form.
Yeah, and to graph them.
Okay. I'm guessing we're using a variation of de Moore's theorem that says this. got to remember how it goes. Hold on. Let me look it up real quick. Sorry.
Yeah.
I know that I think this is in here, and then this is the cosine of theta divided by n plus I sine of theta divided by n. And this might be 1 over n here. Or maybe it's r to the n here. What power is the cube root?
3.
Okay, if I write it this way, how do I express it as an exponent?
2 to the 2. Yeah.
That would be equal to 2, but it would be equal to 8 to the third, right?
Oh, yeah.
And I know that there's a spin-off on the Morse theorem that basically uses that. Instead of n, it's like 1 over n. I just have to look for it. I want to make sure I give you the right equation. 855. So this is 1 over n. I basically have the right equation.
Mhm.
And so I'm going to write r as a complex number. So this is 8 plus 0i. Okay?
Okay. Wait, what was the first thing again? Oh, wait.
Do you see it?
Yeah.
So when I look at my original r would be grafted like this. Where this number is 8. Okay?
Mm-hmm.
Now I'm going to figure out what my theta is. So what is theta there? If I'll make the line in red so it doesn't look. So that's my line. How many degrees is it for theta? Do you know?
Oh, just 0.
It's just 0. It's just 0. So what I'm going to do is I'm going to is it from 0 to 2 pi? So I'm going to rewrite this equation. This is 2. I'll rewrite it all the way out. So this would be 8 times 1 over 3. And this is the cosine of 0 over 3 plus I sine of 0 over 3. And there might even be a k value here. I'm going to have to look it up. Sorry. Because I think k is an integer, so we're going to keep on going around the circle until we find all of them from 0 to 2 pi, if I remember correctly. That's actually what they do. So if I'm looking for this, and I know when I stick it in for R, I get this, right?
Mm-hmm. Yeah.
So this would be equal to 8 times 1 plus 0. And then I'm going to say that because I'm looking for the cube roots, I'm going to say that 3 theta is equal to 0 plus 2 pi k. Because I'm using the cube root, that's where this 3 number comes from.
Mm-hmm.
This number comes from the original angle, which was 0, right?
Yeah.
And then it repeats itself every 2k pi. What is 2 pi equal to?
360 degrees.
360 degrees, so it's a full circle. That's how often the pattern's going to repeat itself, right?
Mm-hmm.
So then I can say that theta is equal to 2 pi k over 3. Do you see how I solve that?
Yeah.
And so now that I know what my theta is, when I'm using this formula, I can now substitute that in for theta here. So I'm going to have r to the n is equal to r to the n over 1 is equal to r to the n over 1 times the cosine of 2 pi k over 3 plus the sine of 2 pi k over 3.
Mm-hmm.
So when I'm using this equation here, that one right there, I'm just redefining what my theta is due to how many roots I have.
Okay.
And then I'm going to substitute that in to the thetas here. Do you see how I just substituted that in?
Mm-hmm. Yeah.
And so now I literally need to make a chart. So let me erase some of this stuff because I don't want it to be all over the place. Probably would have been easier for me to just do this. I didn't even think about it. Okay, so I'm just going to make a chart. This is my n or my k value, and this is going to be my new r. So I'm going to write the equation here. So, and here's the other thing. I'm going to change this so it's just like what should be in your book. and so it's less confusing, I'm going to call that value z to the 1 over n, because z is the actual complex number. Okay? So I'm going to call this value z here. So here's my equation. I have 2 times the cosine of 2 pi k over 3 plus I sine of 2 pi k over 3. And I'm just going to change the value for k. When k is equal to 0, if I stick 0 in where these k's are, what is the cosine equal to if you stick in 0 there?
0.
Right? So you get the cosine of 0, and then you plus I sine of 0 times 2. So what's the cosine of 0?
0.
Remember, cosine is the x part, right?
Yeah.
So if I have my graph here, and I got the cosine is 0, and the cosine is 0 here along this line, then that would be 1, and the sine is 0. Do you remember that from the unit circle?
Yeah.
So this becomes 1, and then this becomes 0. So our first number would be 2. So z is equal to 2 there. When I stick in 1 for k, then I get this. And I'll do the first couple of them for you. So I get 2 times the cosine of 2 pi over 3 plus the sine of 2 pi over 3. Do you see where I got those numbers from? Again, this is from our unit circle. So I have 2 times the cosine of 2 pi over 3, which is negative 1/2, plus the sine of 2 pi over 3, which is square root of 3 over 2. Do you know where I got those values from?
Yeah.
So when I multiply this by 2, I get negative 1/2 plus the square root of 3i. Do you see that part? And that value would be over here. Do you see how I graph that?
Yeah.
Okay, so I want you to do so that I get negative 1/2 plus root 3i. So I want you to stick in 2 for me. And tell me the value that you get. Because I want to make sure that you understand what I'm doing. Good. Are you guys playing like pool over there or something?
No, my little sister's in here and she's playing with some magnets on the table. Mute.
Okay. I'll move this out of the way for you. If you need help, I'll help you.
Yeah, I'm trying to. I mean, yeah, I don't know. Sorry.
Okay. Let's do it a piece at a time. What's the cube root of 8?
2.
2. So go ahead and write that number down. You know that one. Okay. Now, are you going to be given a unit circle for your test, or do you have to memorize a unit circle?
There is. I get one note card to write anything I need on it.
Okay. I would suggest that you make sure that you write the unit circle up then.
Okay.
Okay. Anytime you see a 3 here at the bottom, here's an easy way to remember it. Anytime you see a 3 written in the bottom of these fractions, these are always going to be the same two numbers. It's just going to tell, the only thing that's going to change is the sign between the two of them. So if you have 4 pi over 3, that is down here. So what are the signs of the numbers in the third quadrant?
Both negative.
They're both negative. So it would be exactly the same two numbers, except for both of those are going to be negative this time. In the exact same order. And there actually shouldn't be a 2 here. That should be 1 because I multiplied it all the way through. Do you get what I'm saying when I say that, or no?
It's, um, just -1.
It's -1, and then instead of being the square root of 3, positive the square root of 3i, the sign just changes.
Um,
And it's actually 1/2, and then it'd be minus the square root of 3 over 2, I. Okay?
so, mhm.
And now multiply the 2 through both of those. And if I'm graphing this, then it would be right here. That's where the line would be.
Mhm.
And then when you do the third one, you're just going to get back to the original line. So that's the graph of that, of the roots of all the roots of the cube root of 8. That's what the graph looks like.
Okay.
It's probably harder for you to understand because you don't understand your unit circle. That's probably where the disconnect is. But if you look at the unit circle, if you can find a chart of it online,
Mhm.
and I actually want you to do that before I leave, okay?
Okay.
Go and Google unit circle. Do you have it up yet?
Yeah. Okay.
Oh, just give me the graph. I hate when it does that. Okay, when you look at 2 pi over 3, what two numbers do you see on that dot? Oh, you don't have it yet? Are you still there?
I didn't have everything, but yeah. What was the question? Compare with
I'm sorry, let's start here. Look at pi over 3.
okay.
What two numbers do you see there?
1/2 and square root of 3/2.
Okay, look at 2 pi over 3. What two numbers do you see there?
-1/2 and root 3/2.
So what is the only thing that changed from pi over 3 to 2 pi over 3?
The negative, or the sign.
The sign. Look at pi over 4. Or sorry, 4 pi over 3. My bad.
-1/2 and negative 3, 5. Sorry,
Yeah.
negative root.
Okay, and look at 5 pi over 3.
1/2 and negative root 3/2.
So you notice that all of the pi over 3's have exactly the same two numbers. The only thing that changes is the sign.
Yeah.
Right?
Mhm.
Look at pi over 6.
Root 3/2 and 1/2.
So what switches from a 6 to a 3?
The X and Y coordinates switch.
Yeah, the order switches, right? Now look at all the pi over 6's. Do you see the same pattern for those?
Yeah.
So the unit circle is only memorizing 3 numbers. 1/2, root 3 over 2, and square root of 2 over 2. Those are the only 3 numbers that are in the unit circle. And you already know from your math knowledge what the sign of each one of them is in each one of the quadrants.
Yeah.
So I know it looks like a ton of numbers, but it really isn't.
Mm-hmm.
If you can just remember what comes first, then you'll know all of the other four.
Yeah.
Do you see the pattern now?
Yeah.
Okay.
Mm-hmm.
And then you just plug those numbers into that formula, and then you simplify. And then it'll give you a line. Do you see why I drew the 3 lines where I drew them? Do you see where 2 pi over 3 is?
Yeah.
Is it the same as the one in the picture, basically?
Yeah.
Do you see where 4 pi over 3 is?
Mm-hmm. Yeah.
So I'm basically adding 120 degrees when I have those cube roots of 8.
Yeah.
And 3 times 120 is 360, and that's why the pattern just repeats itself. That's why there's only 3 lines.
Mm-hmm.
Do you see that now?
Yeah.
So the only thing that changes is if the number of roots were to become 8, then your n would change. So if you were to have like 5 roots of 8, then you would change that n to a 5 and do the exact same process again. It's the exact same thing.
Okay.
So
Right.
this is what I'm saying to you. I'm going to erase all of this.
Mm-hmm.
If you were given the question, find the 5th roots of 2. They're telling you what your 1 over n is equal to.
Mm-hmm.
So we're going to use this number to determine what our z value is, our original z, right? So I would plot 1, 2, there's my dot. So I have to use this number to find my original theta. So how many degrees do I have if it's sitting on the x-axis?
0.
0. So the same thing is going to happen again, right? And
Mm-hmm.
so my original theta is going to be 0. So theta is equal to 0. Now I want to find all the rest of them. So what I do is I use this equation, 5 theta, because that's my n number,
Mm-hmm.
is equal to my original angle, which is 0, because that came from this number, plus 2 pi k. Because the pattern is going to repeat itself every 360 degrees. If I have my 2 and it's originally there, the pattern doesn't repeat itself until I go all the way around the circle, right?
Yeah.
And how many degrees is all the way around the circle?
360.
And another way of saying 360 in radians is saying 2 pi.
Mm-hmm.
And so to plug into that formula, I have to solve this equation for theta. And that's what I did before. So I get theta is equal to 2 pi k divided by 5. And so that becomes my new theta. That's why I substituted it in before.
Mm-hmm.
And then I write the equation all the way out, and I just change the value of k. I change it from 1 to 2 to 3 to 4 until the pattern repeats itself.
Okay. Alright. Okay. That's...
So if I'm drawing it out, then how many lines should I be drawing in this graph? Look at the last question that we did. Do you remember how many lines I drew?
3.
3. So how many lines do you think I should draw on this graph?
Is...
Remember, this was my original value of theta.
So 5.
So you should draw 5 lines. So when you graph that thing, you should have 5 lines in your picture.
Okay.
That's the pattern. Even though I changed the numbers, that's how the numbers actually work.
Mm-hmm.
So we just substitute in, and then we would solve for each one of those new lines.
Okay.
So your picture is actually going to look like and each one of these angles is the exact same amount as you go around the circle. So what is 5 divided by 360? Can you do that in a calculator for me?
Yeah.
I think it's 72, maybe?
Yeah.
So it would be 72 degrees between each one of these.
Okay.
Does that make a little more sense now?
Yeah.
Okay. Is your exam Monday?
Tuesday.
Do you want to meet one more time?
Um.
Or are you good?
Sure. I have to ask my parents. Neither of them are here right now.
Okay, that's fine. Just have your dad give me a call or send me a text message, or you can call me back. Either way, I am pretty much open all day long on Monday once you get out of school, so I can actually meet you at the same time at like 10 o'clock at night if you need me to.
Okay.
If not, good luck on your exam. Please text me and let me know how you did.
Okay. Thank you.
All right, you're so welcome. Have a really good weekend.
You too.
All
Thanks.
right, all right, bye.